Good evening, everybody. I'd like to start off tonight with the Pledge of Allegiance. I pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you for coming out. Thank you. We have a guest speaker tonight. Ed.
Thanks, everyone. Can I stand in front of this? Good evening, everybody.
Good evening.
Good evening, Ed.
Good evening, everybody.
Good evening, Ed.
Okay. So just a couple of quick announcements before we get started. First off, are there any guests tonight? Please, tell us a little about who you are and your call.
Peter, KC2ASA. I live in Rockland County in Sloatsburg. Extra class. Been a ham since '97. Here's an interesting fact. My wife got me involved when we were dating. There's a longer history of that, but usually the female is not the first one licensed. But I'm usually up in Orange County Club up there, OCARC.
Yep.
They have their meetings tonight, but I have to get up early, and your meeting was closer to me, so I came in here. Plus, there was a cool topic that I wanted to hear about.
You got it. So we're glad to have you. Welcome. Any other guests? Any other guests? Pioneer Amateur Radio Club's here tonight, right? Welcome. Okay, great. So any other guests? Okay, just a few quick announcements. Don't forget, for the club, we've got a couple of things coming up. April 13th, we'll be here before you know it, is our Earth Day special event station, okay, at Great Falls National Historical Park. So we'll be running, what's our call sign? W2E, water to electricity. So it's going to be really fun. It's a one-day event on Friday. Obviously, all the help we can get will be greatly appreciated. So, I mean, just, come down to the park. We'll have details in the resonator, okay, and I think it'll be a really fun day, okay, as it has been in the past in terms of working with the kids, and just getting a special event station out. Coming up speakers, April 20th, Alan Wolke, W2AEW will be here, talking about oscilloscopes and a whole lot more. That's our rough working topic for right now, right?
What we expect out of that is it'll be a good demonstration of test equipment for use with and for use of around amateur radio stations and basics of using them with circuits. So it should be interesting. It should be a little bit about test equipment and ham radio combined.
Perfect. May 12th is Portable Day with Barrett, okay, down at Memorial Park. And on May 18th, our speaker will be Steve Nordahl, NS3L from AMSAT, who will be talking about getting started with satellites. Okay, and it's a really interesting presentation. Actually has some actual satellites to take a look at, and obviously talking a little bit about getting on the air and getting into satellites. So again, that's May 18th. Just in terms of community events, April 29th is the Arbor Day celebration we'll be doing down at the Arboretum on Fairlawn Avenue. And then on June 10th is the Radburn Street Fair. So again, if you're interested, we're always looking for volunteers, to work those events. The Arbor Day is basically 3 hours. The Radburn Street Fair is obviously pretty much the day. But it's really a lot of fun and a chance to meet a lot of people. And I know a lot of you have come through street fairs, okay? I'm looking at Dave, MOB, okay? So thank you all. Also, just in terms of looking at the Monday Night Net, just a reminder, we need net controls for both April, May, and June. So I know I did send the first list around, but I'll send it around again. So please volunteer, or else, okay? So, and with that, okay, let me just turn the program over to, I guess, who's become a person who's become an old friend of this club. So Nathaniel Frissell, W2NAF. As you recall, last year we were a participant, in the QSO party, the Solar Eclipse QSO party. And Randy, Tom, and I had the honor, I think 2 weekends ago, of being part of the HamSCI consortium that Nathaniel put on at NJIT. And we're only going to see one small sliver of really 2 days of really intense scientific cooperation between scientists in the field, professional scientists, and amateur radio operators. So, I think I would always say Nathaniel needs no introduction, but I'll give you a brief one. Okay, he's obviously a research professor at NJIT, for their Technical Center for Solar-Terrestrial Research. His interest in ionosphere started when he was young, right? Graduate of Montclair State, and his MS and PhD in electrical engineering is from Virginia Tech and the Super Darn Laboratory. He spent a lot of time in Antarctica, as we've heard. Great career. A good friend of this club, and without further ado, let me welcome back Nathaniel Frissell.
Thank you very much, Ed. It's a pleasure to be here this evening. And thank you so much for having me back and for letting me tell you about what I found so far from the Solar Eclipse QSO party. So first of all, I just want to see a show of hands. How many people here operated in the SEQP? Good, quite a few people. That's really good. Did you enjoy it?
Oh, yeah.
Yeah? Did you notice anything on the bands as you were operating? Did you notice any changes? Yes, that's great. So hopefully the things I will show you today will correspond with what you noticed. And hopefully I'll show you a couple subtle things that you probably wouldn't notice and we're looking into more now. So as a review, we had this eclipse on August 21st, 2017, this past August. And this was a very special total solar eclipse because it covered the entire continental United States. It started, totality started in Oregon at 1716 UT and ended in South Carolina at 1851 UT. So it took just about 90 minutes for totality to go across the entire United States. And I made a movie of that, so I was able to go online and I used a library called AstroPy, and I wrote a Python program to do a little visualization of what the obscuration looked like across the United States. So I'm going to play that right now for you. There you can see the shadow move across. And so you can see that totality, the region of totality is very narrow. It's only, about not even 100 kilometers in diameter, I think. But the entire United States experienced some of the eclipse, at least a partial eclipse, throughout the entire continental United States. And I'll play that one more time. Now this map is a little bit different from a lot of the maps you have seen, say, online or in the news. And the reason for that is this particular obscuration map was calculated for 300 kilometers altitude. And so that's, of course, of interest to ham radio operators because that's right in the F region of the ionosphere. And so the eclipse occurs at a slightly different place, higher in altitude than lower. And you can see that better in this next movie. So it's the same movie, except what I did was I took the movie you just saw and I made another one for at the ground and I subtracted the two. And so wherever you see blue, that is, I made the 300 kilometers altitude minus the ground, and the blue are the positive numbers and the red are the negative numbers. So wherever you see blue, that's the ionosphere is more eclipsed than the ground, and wherever you see red, the ground is more eclipsed than the ionosphere. So this will give you an idea of some of the differences you can see. So it starts off mostly blue, and then you get more red afterward. And you see this rotation as you go through local noon. So I'll play that one more time. So it's really interesting to see the differences between what the ionosphere is going to see in terms of the eclipse and what the ground is going to see. Okay. So a little bit more background in terms of what we do. Most of you here are probably familiar with the concept of ionospheric refraction and multi-hop skip propagation. Maybe if you're new to ham radio, you're less familiar with it, but if you've been around a while, this is kind of like an old friend. So what we have here, these are some ray traces, and I don't think I showed these particular ray traces the last time I was here, because these, so what a ray trace diagram is in HF radio is we take a numerical representation or a numerical model of the ionospheric electron densities, and then we're able to use equations, they're called the Rutherford or the Appleton-Hartree equations, to calculate where we expect the radio wave to go to. These are just 2D ray traces, but here we're using 7 megahertz, And the transmitter's here, and then this is about 2,000 kilometers away, and the background is the electron density, so the F region is this yellow band right here. And we just launched rays at many different elevation angles, and you can see that the computer is able to predict where each of those rays are going. And again, this is for 7 megahertz, and this is going that we modeled a station in Georgia going to an RBN receiver, Whiskey Echo 9 Victor in Wisconsin. And so you can see what we predict. Now, the numerical model we used here was provided to us by the Naval Research Laboratory. It's something called the STAMI-3 ionosphere. And this is what they predict happens on a normal August 21st day, as if there were no eclipse. Now, if there is an eclipse, you can see that this is their prediction of what would happen with the eclipse going on. You see that the electron densities have been reduced. So the colors are much more muted here. And what do you notice about what the ray paths are doing?
2 hot versus 3 hot.
Right, we have so less electron density, less bending. The paths are getting longer. And so this is for a 7 megahertz band. And so that's one of the things we expect to see. We expect to see the 7 megahertz 40 meter band open up and get longer. So that's one of the predictions that's being made. So this is an example. And so one of my goals was to create a ham radio event that would give us a whole bunch of data to let us test models out like this and try and find out new things about the ionosphere, or at least confirm things that we already know just based on what ham radio operators do normally. So I did set out with a few research questions, and some of those questions are like, what are the temporal and spatial scales of the eclipse-induced ionospheric effects? So like if you have an eclipse, how long does it cause an effect change the propagation that we see? How wide-reaching are those changes? Can we observe TIDs? These are traveling ionospheric disturbances in the ionosphere caused by the eclipse. Or can we observe other interesting wave features caused by the eclipse? How does the eclipse affect HF propagation? So those are some of my questions. Now, I was very fortunate because I was able to travel to Gilbertville, Kentucky, to the Moores Resort, and I was able to set up a station there underneath Totality. And so one of my friends who lives in the area, Jim Sackerman, KC2ZFK, he took this photo of Totality from where I was located. It was just beautiful. And then another friend of mine, Bill Engelke, he was at a different location. He's Alpha Bravo 4 Echo Juliet, and you may know the website DX Display. That's his website. He took this photo. So these are some photos taken by hams of Totality during this past eclipse. So many different ionospheric experiments were taking place during the eclipse. And the reason for that is the eclipse is one of the few times in ionospheric science where we really know what the input changes to the ionosphere are before they actually happen. So a lot of times we are interested in the response of the ionosphere to solar flares or to geomagnetic storms. But those things we have a very hard time predicting, and they're very irregular. With the eclipse, we can know exactly when the shadow is going to be and where it's going to be and how much obscuration is going to be at each point before it happens. And then we can go back and we can test different hypotheses and look for things in a different way than we normally would be able to. So many different experiments are going on, both in the professional world and also in the ham radio world. So from the ham radio side of things, HamSCI, the Ham Radio Science Citizen Investigation, we promoted 3 main experiments. One was the Solar Eclipse QSO party, which many of you participated in, and that was a contest-like event. The RSGB did one a few years ago for their partial eclipse, so we're kind of following in that tradition of ham radio experiments. One difference between this one that I organized and the RSGB one was I wanted this to kind of feel like a regular contest almost. I wanted to just flood the airways with a lot of signals and get a quasi-random data set and see what we would get. And one of the reasons for that, I wanted that, was because, you know, ham radio operators, many of you really enjoy participating in contests. So it's something you do on a regular basis anyway. So it kind of plays to those contesters' strengths. And it also says, okay, here's a data set we can look at to look at this eclipse. You know, contests happen many times a year. So if we have some experience using a contest-like data during the eclipse, then we can go back and look at other contests too and maybe use that information to study other things as well. So that was the motivation behind that. The other nice thing is the reverse beacon network, PSK reporter, they're perfect, you know, systems that already exist to observe what's going on and collect lots of data. And then WhisperNet, while not really good for observing what's going on in a contest, it's an extremely popular digital mode that generates lots of HF data. So that's good. And then we also got the logs that were submitted by participants. We also promoted wideband recording, where you could just take your software-defined radio, you could record what you heard, and you can send it in. And we now have a number of hard drives sitting in my office that need to be looked at. And we also have many people have posted their recordings onto an open source data sharing website, Zenodo. So anyone who's interested in looking in that wideband recording data, you can just go onto the Zenodo.org HamSCI community, and you can go look at those recordings yourself. And then we also had the HF frequency measurement experiment. And this was really nice because there are a number of hams that are extremely technical and are interested in making very fine measurements of frequency changes. Twice a year, the ARRL has a frequency measurement test. How many people participate in that? Anyone here? So we have one person who participates in the frequency measurement. And that's neat because you need a little bit more technical skill and more equipment than your standard just buying an off-the-shelf, you know, ham radio and plugging it in. You need to do a little bit more engineering, a little bit more work to get good measurements for the frequency measurement test. But the people who are in that FMT community are extremely skilled, and some of them just have rubidium and cesium standards sitting in their basements, and they are like ready and able to go make measurements of, say, WWV. And I'll show you some really beautiful measurements that one ham sent in to me. So before we look at the actual data, I just want to remind people that we have this thing called space weather. So just like, you know, you go outside and you say, is it sunny or is it rainy? And if it's sunny, you're happy and you can go outside and enjoy the day. And if it's rainy, you know, some type of people will go outside and still enjoy the day. And other type of people will be like, oh, it's raining. This is kind of throwing a wrench in my plans. You know, you need to be aware of that. Well, same thing for this. We're trying to collect all this data about the eclipse, but what would happen if there's some sort of geomagnetic storm or, you know, or solar flare that happens during the eclipse? That would mean that the observations that we're seeing in our eclipse data might be contaminated by these other things, and we have to account for that somehow. So I looked at the geomagnetic conditions during the solar eclipse QSO party. So the white area here, this is from 14 to 22 Universal Time on August 21st, 2017. That's the period of the solar eclipse QSO party. And the short story is basically things were geomagnetically quiet. So we were very fortunate that there wasn't a big solar storm or a big geomagnetic disturbance to kind of throw off the eclipse observations. So we're very fortunate. The observations on top are from what's called the Discover satellite, and that is a spacecraft that sits at the Lagrange 1 point. It's, whoops, going the wrong way here. The Discover satellite sits at the gravitational balance point between the sun and the Earth. This is not to scale, I should point out. But what is important to note is that that particular spacecraft sits somewhere in this region outside of the Earth's magnetosphere. So it's monitoring just the raw upstream solar wind parameters in interplanetary magnetic field before it interacts with the magnetosphere. And so all of these, the interplanetary magnetic field, plasma pressures and the plasma velocities and the plasma temperatures of the solar wind. Those are all within nominal values. And then down here I have Kp, the planetary K index, which most hams are used to. That's all less than about 3, which is considered quiet. So we were very fortunate. I also looked at the GOES geostationary operational environmental satellite, the X-ray flux. This is the satellite that we use to monitor whether or not there are solar flares. You may hear of like an X-class solar flare coming and causing widespread HF radio blackout. So this satellite showed that for that day there were only 2 very minor flares. They were C-class flares and they were later in the day. And you can see some effect in some of the data, but overall it wasn't too much. I'll show you some of the effects that they can have. But generally, we were very, very, very lucky with that. Now, I told you before that the frequency measurement community is very good at making measurements of how frequencies change over time to very, very accurate values. And one of these people, WA9VNJ, Steve Ryer, he is located out here near Milwaukee. He was using his equipment to just monitor WWV at 10 megahertz. And so he was just looking for Doppler shifts or frequency changes from WWV over time. And he sent me 2 sets of data. One is from August 20th, the day before the solar eclipse. And that is his control data, and that's what you're seeing here. So right here you have, right down the center, this is a 10 megahertz line. And then up here, this is this is a 0.1 hertz higher than 10 megahertz. This is 0.2 hertz higher, 0.3 hertz higher. So you can see that we're measuring at less than 0.1 of a hertz here. And these are very fine measurements. And you can see at the beginning of the day, we see a positive shift in frequency. And so what we take that to mean is that the paths, the propagation paths are likely getting shorter because the ionosphere is getting lower as the ionosphere builds up in the morning. So you see those paths getting shorter as the ionosphere gets lower, and then things stabilize. And then as the evening comes on and the ionosphere starts to become less dense, it raises up and the propagation paths get longer again. And so you get this negative frequency shift here.
What's that peak to?
That's an excellent question. I'm so glad you asked. You've got good eyes over there. So yes, what is that peak there?